Welcome. My name is Sonja Birthisel. I'm a PhD student at University of Maine and one of the coordinators for the USDA Northeast Climate Hub's GradCAP program. We are a virtual consortium of master's and doctoral students working on climate adaptation in agriculture, aquaculture, and forestry. Today's webinar on changing ecosystems will highlight the work of 3 GradCAP scholars. Welcome. We're glad you've tuned in. A quick housekeeping announcement. This webinar is being recorded for subsequent viewing. Now, it's my pleasure to introduce today's speakers. Gordon Dimmig is a master's student in wildlife and fisheries resources at West Virginia University and will share his work on avian temporal dynamics in Appalachia. Manashi Paul is a PhD student in the Environmental Science and Technology Department at University of Maryland College Park and will share her work on sustainable water use. And I'm your third presenter today and will be sharing preliminary findings related to effects of changing precipitation on agricultural fieldwork. After all 3 presentations, we'll have time at the end for a joint Q&A. You're encouraged to type questions into the chat box throughout our presentation today so we can refer back to these at the end to help guide the Q&A. All right, that's all for announcements. Without further ado, I will turn the mic over to Gordon Dimmig from West Virginia University.
All right, thanks, Sonja. And as you've heard, I'm Gordon Dimmig from West Virginia University, and I'll be talking about some of my master's research that I'm currently working on, which is avian temporal dynamics on a central Appalachian elevation gradient. So we'll be talking about birds as their distributions across this mountainous area. So first, to give you a little background, the Central Appalachian Mountains have a really steep elevation gradient and rugged topography. And this elevation gradient can span over 4,000 feet in elevation change.
Along with that comes pretty unique climatic conditions. So there's often cooler temperatures and increased precipitation levels in these mountaintop areas. And this leads to a pretty diverse array of forest types that can be found throughout this area. So here you can see just a sort of general gradient of forest types that can be found throughout the Appalachian Mountains, where in the low elevations it's often oak mesophytic forest, and then that gradually transitions into more northern hardwood forest. And then finally, when you get up in the really high elevation areas, that will transition into boreal type forest that pretty closely resembles what you might find in the Canadian boreal forest. So this diversity of forest types also leads to a pretty diverse songbird communities that can be found throughout the Appalachian Mountains. So here you can see some data that we have from the Appalachians in West Virginia with several species of warblers and their elevational distribution. And you can see that these warblers follow a pretty nice gradient of distributions along the elevation gradient as well. So this gradient of bird species that can be found here lends itself nicely to looking at how these birds might be changing through time along the elevation gradient, if they're moving up in elevation or just to see what's going on with these warbler species and other songbird species. So as you may have guessed, climate change can have a pretty big role in how these birds might be found along the elevation gradient. So here's some temperature data from May through July, the mean high temperature in Elkins, West Virginia, which is the closest place to where our study area is in the Appalachian Mountains. And you can see while there's a fair bit of noise from year to year, there is a fairly strong upward trend in temperature here. So with these increasing temperatures, what's expected? What do we think is going to be happening with these birds along that gradient? Well, the first thing is that these low elevation species that you can see here, like the wood thrush and scarlet tanager and many other species, they may be forced upwards and begin to colonize some higher elevation areas. Additionally, these high elevation species may contract their range further upwards. And if they're in these mountaintop sites in the Appalachians, they may experience some local extinctions in some areas. But it's not only important to look at single species movements, but we also want to look at how communities might be changing over time. So there's the potential for communities to pretty drastically change in their assemblages and in their organization. So say we have that our nice little community of birds here, and if these low elevation species move upwards, then that community in the high elevations is pretty drastically changed, and there's new interactions between species that we don't really know what could occur with that change of community. So what's actually being observed from past data? Well, it's not really so simple, unfortunately. So we don't really have the luxury of controlling other variables like in an experiment. So there's many other factors that can influence where species might be found and how they might be moving along that gradient. So one big factor is forest succession and the change of forests through their structure and composition. And this can play a huge role in where these birds might be found. Another big wrench in the situation here is that every species and guild has the potential to respond differently to these changing conditions. So with varying life history traits and varying behavior, these species can respond differently, which makes it a little bit more difficult to assess what's going on. So there's several past studies that have looked at this question on elevation gradient, and they have observed a fair amount of upward shifts in species. Not all species, but a good portion of species do show some upward shifts. But there's also some downward shifts that have been being observed, which is a little bit harder to explain. Some have suggested that changes in precipitation might play a role there, but it's important to account for other factors that might play a role in that shift. So with that, there's still a lot of unknowns in this question. So our goal for this project was to assess avian community dynamics between 1993 and 2018 along that elevation gradient in the Monongahela National Forest in West Virginia. So there's three parts to that question. We wanted to look at colonization rates or extinction rates of species, as well as the colonization rates of species, the local rates of where birds are colonizing. And then also we wanted to incorporate a metric of turnover and to sort of account for changes in the community level. So turnover is a metric of how similar or dissimilar a community of birds is from year to year. So we wanted to see if that varied along the elevation gradient. So our study area for this project is the Monongahela National Forest in West Virginia. So it's in the eastern part of the state, and it pretty closely follows the Appalachian Mountains down through West Virginia. So you can see it's a fairly large area. It's about 1.7 million acres, and we placed several point count transects throughout the public land in this area. And the important component of this project is that we have historic avian point count data since 1993. So we have about 25 years of data throughout this area that we can look at these temporal trends. So just to give you a little background on the methods for collecting this data, we used a 10-minute unlimited radius point count method. So we just recorded all species seen and heard during that 10-minute period. And in 2017 and 2018, I continued this historic data set and conducted 840 point count surveys. We also collected some detection covariates like date, time, wind speed, sky condition. And then we also did some vegetation plots to try and get at the forest composition and structure at each site to hopefully account for that in our models. To select points, we revisited many of the historic transects, and sampling was stratified into 3 elevation classes to ensure that we conducted point counts along that entire elevation gradient. So within a transect, there were about 10 to 12 points spaced 300 meters apart, and some were off-road, as you can see on the left, and then others followed along trails throughout the public land there. So once we had our data, we are planning to create some dynamic multi-species occupancy models. So within this model, we'll be able to calculate the colonization and extinction probabilities of these species. And this is the local colonization and extinction probability. So it's not like if the bird will disappear from our whole study area, but the probability of it going locally extinct, or the probability of it locally colonizing a site. And we hope to model that as a function of elevation to see if there's differences along that gradient. And then we also hope to account for these changing habitat conditions that I mentioned can play a pretty big role. And then finally, using the estimated colonization and extinction probabilities, we hope to model turnover to get at that community metric and model that as a function of elevation as well. So unfortunately, I don't have any results yet since it's a work in progress, but I'll just go through some of the expected results. So here you can see the probability of colonization on the y-axis, and for low elevation species, we expect that the probability of colonization will be positively correlated with elevation. So essentially, birds are colonizing these higher elevation areas and moving their range upwards. So on the flip side of that, the extinction rate of high elevation species, we hypothesize that it'll be negatively correlated with elevation. So there's higher extinction probabilities at these low elevations, which would indicate that these high elevation birds are contracting the range upwards and going locally extinct at those lower elevation sites. And then finally, for turnover, we expect that the turnover rate of these bird communities will increase with increasing elevation. So basically, these higher elevation communities will be changing more quickly and be more unstable through time. So that's what's expected, and I'll throw in just a little bit of preliminary data on one species of bird, the veery, which is a type of thrush. So this is just the raw data and their elevational distribution from year to year. And you can see, while there is a fair bit of noise and ups and downs, there might be some downward movement of this bird, but it's tough to tell. I mean, that's just anecdotal. So hopefully this graph kind of shows the limitations of just looking at the raw data of these species. So hopefully our occupancy models will be able to estimate their distribution a little more precisely, while also accounting for some other habitat factors and things like that. So we can basically hold habitat type constant and then see if birds are colonizing along the elevation gradient. And then we'll also be able to incorporate uncertainty into our estimates, which is definitely an important thing to consider when modeling these bird distributions. So sorry I don't have a whole lot of results yet, but I hope you enjoyed the talk, and thanks for listening. And I'd like to thank the support of my committee members as well as the U.S. Forest Service that we were coordinating with a fair amount for this project. And then there have been countless point count technicians over the past 25 years that have collected all this data. So thanks for listening.
Thank you, Gordon. That was really interesting. Next up on our presentation list for today is Manashi Paul from University of Maryland. And please bear with me for just one moment while I call up Manashi's presentation. A reminder that if you have questions for Gordon and Manashi as she goes through her presentation, leave them in the question box on the right. All right, Manashi, take it away.
Hello, everyone. Welcome to my presentation today. So we all are experiencing that ongoing climate variability and changes around us, and even from our research, we are getting the evidence like that our climate is changing. And so how can we deal with this unpredictable climate? This is the topic for today's presentation. Before going to my details presentation, I want to just give a outline for the background, like how climate change is really important for us. So if we already know that climate, water, and food, all three elements are very interrelated to each other. And a balanced climate condition is very important for the healthy ecosystem that provides like sufficient water and food to sustain development. And if this climate is happening ongoing, happening day by day, which is actually give a weak condition for the weak food and fresh water supplies. That means like if climate and water and food balance is falling out, it will give a very critical condition for food, water, and energy security. And we already 2/3 of our world's population living in a vast stress region, and it is saying like by 2025, almost 1.8 billion people will live in an area where there will be the severe water scarcity. So what's actually going on in USA? When we look at the long-term change in USA, we can see there is a lots of there was happening like precipitation increasing in the Midwest and the Northeast region, and in others region they are having like decreasing pattern for precipitations. But not only the precipitation, if you look at the temperature change, they are increasing that all the US upper side of the US, and they have also that facing that decreasing temperature changes in this region. But if you look at the short-term change, especially the seasonal variations in the individual region, you can see that even in the short-term period, that climate is changing very drastically. So for an example, I pull out two drought maps just 2 weeks apart from Drought Monitor website, one from July 17 and another is July 31. You can see even that 2 weeks apart, there was like a very drastic change of that abnormally dry condition and moderate drought to normal conditions. You can see that the drought condition was changing from one region to another regions just 2 weeks 2 weeks apart. And if you look at the Maryland portions, that here was the very abnormally dry condition in July 17, and just 2 weeks later that condition was gone. What happened in here? So when to look in the data, we saw that like in this year, first 2 weeks was there was no rain at all, so it was very dry. But in the second 2 weeks of the July, we have 16.7 inch rainfall, which was the second highest on record. So you can see like even in a short terms, especially in the growing period, how it's dramatically changed. And what's actually happened for the demand conditions? Like, okay, climate is changed, but is the demand also changing? Yes. For mid-Atlantic regions, you can see that irrigation, demand for irrigation is increasing day by day, and it's more than 100 to 100%, and in other states it was more than 250%. And to 50%, and you know that irrigation actually use almost 70% of freshwater withdrawals. And if you look into closer to for the Maryland, you can see like over the years for other sectors like industrial or public supply, that water usage was increasing and decreasing. It was not like in a constant way. But for irrigation sector, you can see there is a very mild, constant increasing pattern. And even in recent years, you can see that increasing patterns actually causing the water uses of industrial sector. So from where that irrigation sector taking water for their irrigation purpose. So they mainly use the groundwater with the help of surface water, but it's mainly dependent on the groundwater source. And now if you look at that, like from where that Maryland state taking their groundwater, so they are taking from different kind of aquifers. It's a shallow aquifer or deep aquifer like that, and the whole state is divided in 4 or 5 regions based on their aquifer characteristics. And here these are only the shallow aquifers. So based on regulations in Maryland, there is no strict regulation for using the groundwater. And we was talking to the policymaker from Maryland Department of Environment. They said like you can use the you can apply for the groundwater use for shallow aquifer, and for the license they are just looking into the previous condition, like what will how it will impact your nearest neighbor. Otherwise they are not looking to anything. They just give the license to the people if they are asking for it. So like what actually happens, like users of groundwater users is getting increased day by day, and which actually having an adverse impact on the environment. How? Of course that groundwater depletion is happening, and the demand is so high, it is not cope up with that groundwater recharge condition, and as a result it's giving a lack of productive aquifer. And not only that, it also having problem with that other quality issue like soil water intrusion, since it's situated near the coastal area. They also facing that arsenic problem, nitrate problem, and pesticides. So it's a very giving a very drawback for the groundwater users. So not only for that, this one so how can we see like where's actually the groundwater depletion is happening. So for, some of our colleagues already create groundwater depletion maps for Maryland in this year. So this result is not published yet, but we can see in that published results like that groundwater depletion mainly happened in these regions, in these counties, whereas the cultivate acreage is more than 50%. And if you look at that, like here's all that groundwater depletion happen in these regions, and whereas there's all the cultivated acreage. So how can we deal with this crisis? So for that we need like alternative options. And so is it the only one reason to use the alternative option? No. In our region, like mainly in the Northeast region, we have the other main problem is like we have to reduce our nutrient load on Chesapeake Bay, and there's lots of users, lots of community who wants fresh water, and there's conflicts of these local water users. And if you use the alternative water source, you can give a scope to the groundwater to recharge it back in its normal conditions. And not only that, the recycled water is to give you a reliable water source. It will give you the flexibility to deal with that unpredictable climate. And for this recycled water, what we are thinking in our project, in our research, we were thinking to use that recycled water from wastewater treatment plant. And it's not easy. It's because there's lots of barriers to use this recycled water in the irrigation. First, you have to think about the supply and demand. You have to look at the location of that wastewater treatment plant, and then how much water they are discharging and how much water you need in your irrigation sectors. And second, you have to look at the regularity consideration. That means you have to treat this water in such a manner like you can use it in your food productions. And third is public perception. You have to look and think about the people, like how they are thinking about using recycled water to grow their food. And of course, you have to think about the pricing conditions and the technological barriers, like how can you supply this recycled water from wastewater treatment plant to the irrigation point. So all these things cooperate in our project objectives. So our objective is to find out and identify that wastewater treatment plant locations, and then quantify and qualify their water based on their quantity and quality, and classify them and put in a spatial database. Whereas we can create a develop a decision support system which will help the decision makers. So we collected the data for 4 states because our project focuses in 4 states which is situated 2 different regions. One is West Coastal region and one is like in Northeast region. So in the West Coast region, our focus is California and Arizona, and here is Maryland and Delaware. And in Maryland, so right now I'm just showing the map for the Maryland. So we collected all the data for all 4 states, like how and categories based on their size, like how much water they are discharging to the natural bodies. So for the with the size, you can see the capacity of these wastewater treatment plants, and also with the color, you can see that what's the categories of these, like is it publicly owned or non-publicly owned, is it the major facilities or minor facilities, like that. And then we overlaid this data with the crop data layer. You can see that we are overlaid with the crop data layer of every years. And then we overlaid the data with the watershed boundary and the other natural surface water sources like rivers and lakes, and then soil information. So after creating this platform, we then try to focus into develop the decision support system. So we use all that data which we collected and use the user needs informations and integrate with the modeling software to make a decision support system which will help the help the information to decision makers. So in that spatial multi-criteria decision analysis, we are thinking of different kind of criteria and their sub-criteria, like land cover, like where's the agricultural land is, and what kind of crop is growing over there, non-food crops or food crops. And then we was looking for the climate or water demand, like how rainfall is variability happening in this region, and what's the actual water demand, and categories based on them. Then we also look at the irrigation status, like where's the people actually getting the access to the groundwater, if not, like what's the other sources to get that access, and what's the quality, like how much nutrient loads actually they are discharging from the recycled water, and is it working as a point source pollutions or not. And then the most important one is the wastewater treatment plant information, that is like their capacity, their discharging method, their treatment process, and of course the proximity. So we use that all this information and put in one platform, single platform, and use the GIS-MCDA techniques to create the priority maps. And from these maps, we selected the most high priority zones, and we selected watersheds where we are developing a hydrological model, and we gave the assess the impacts of different irrigation scenarios, including like water reuse scenarios, and then evaluate the hydrological process for these watersheds. We also evaluate that PMPs for different kind of crops, like for Maryland, the main crop is corn and alfalfa. Then we are using the scenarios for these crops. And then at the end, when you're getting the information from the model, we also incorporate with the pricing of the supply and demand pattern extensively. So here I want to mention, like I already mentioned, like our project is focuses in 4 states, and last 2 years we actually working on California states, and this whole approach we applied to the California, and it was a successful application on this, and I got very exciting result for this. But in these presentations I mainly focus in the Maryland condition, and now I'm applying same application for the Maryland, and same approach, and hopefully in the next semester or next year I will give a very good output for this. So thank you for listening, and I want to thank all my committee members and my colleagues and lab partners to support my project from USDA and NIFA. Thank you.
Thank you, Manashi. Very cool. All right, I'm our third presenter for today. My name is Sonja Birthisel. I'm from University of Maine, and bear with me while I call up my presentation. So today I want to tell you about a side project I've been working on. As I said, my name is Sonja. I am a PhD candidate at University of Maine in the Ecology and Environmental Science program and the School of Food and Agriculture. And my work focuses primarily on organic weed management and how climate change might impact weed communities in Maine and the tools and tactics we use to manage them. But today I'm going to tell you about something that's related, but a little bit of a tangent from what I work on every day. So first off, rain can be a bummer for farmers and grad students alike when there's work to be done in the field. This is me having one of my field days rained out. And even after the rain ends, a heavy precipitation event can lead to mud that limits field access for some time thereafter. So if you're a farmer and you need to plant or cultivate for weed control, as Joe is doing in this picture, or perform any kind of field work, soil conditions suitable for the demands of the task are really important. And this leads me to the definition of a field working day, which is most simply defined as a day when it is both dry enough, moisture below some threshold, and warm enough, for example, above freezing, to conduct most agricultural field operations. And I want to talk first about the temperature part of this equation. So with climate change in Maine, as in many places, rising temperatures have already led to a longer warm season. This is a graph from the Maine Climate Futures Report showing temperature on the y-axis and month on the x-axis. And the length of the warm season historically is there in blue. Present warm season as of 2015 is there in tan, and then mid-century projected future length of warm season is in red. And you can see that our seasons are in fact getting longer when you sort of look at frost-free date kinds of conditions at least. But it's important to note that growing season and frost-free period are not necessarily synonymous. In a recent review paper on climate effects to agriculture in the Northeast, Wolf et al. Cautioned this. And what they mean, in part, is that precipitation is also important. And as Manashi mentioned, precipitation in the Northeast has generally been increasing. This is from the same report, historical precipitation in Maine over the period in the 1890s up through present. And we've seen an increase in 6 inches of precipitation on average over that time frame, which works out to 15 centimeters. And trends in this increasing total precipitation and frequency of heavy precipitation events are expected to continue in the future in Maine, which heuristically we would expect might reduce the number of days when soils are dry enough to conduct farm fieldwork operations, which could make it so that farmers have smaller windows to get all of their field work done. But of course, rising temperature also increases evaporation, which potentially could help fields dry out quicker. So it's not cut and dry is kind of what I hope you're beginning to see from this. So knowing this background information, I was curious, have the climate changes that we've already experienced in Maine changed the number and seasonal distribution of field working days. So one day when I was procrastinating on writing my dissertation, I decided to look into this a little bit. I went to the National Ag Statistics Service, which keeps records of the number of days per week suitable for agricultural fieldwork, and I downloaded all the data they had available, which dates back to 1995, available online. And I did a couple analyses, just preliminary things, to see whether there were changes over time. So that's the data I downloaded. After cleaning the data to deal with missing values, which I did in a pretty conservative way, here's what I found. This shows number of days per week suitable for agricultural fieldwork on the y-axis over that period. This is 1996 to 2017, and the red line is a simple linear trend line, according to which we've seen an average reduction in the number of field working days per week of 0.4. So that's almost half a day per week since 1996 that is not available to be out farming. And half a day is enough time to get some real work done. So at least to me, this seems like it may be a meaningful effect. Next, I looked at whether the number of field working days per week, shown here on the y-axis, was significantly related to weekly precipitation totals on the x, and there was a strong, significant negative relationship, showing that the more rain is correlated with fewer days suitable for field work, which of course is not surprising, but it's nice to see reality sort of behave as expected. And I'd be remiss if I didn't mention that these data are consistent with what we hear from farmers about their experiences. I'm part of a group at UMaine called the Maine Climate and Ag Network, and last year we organized a session at the Maine Agricultural Trade Show, an annual meeting of farmers that was entitled Farming in a New Weather Reality, and this was intended to raise awareness about farmer experiences related to increasingly variable weather. So we asked a panel of 5 experienced farmers from different sectors to tell the audience about a story of changing weather on their farms, how impacts they'd seen from weather changes, and how they'd responded. And 4 out of the 5 panelists, this is shown in my parentheses here under perceived weather change, talked about increasing heavy precipitation as a change they had experienced during their careers, and field access was one of the impacts that multiple farmers expressed they had seen. So, what are farmers doing about this? Adaptation measures will be dependent on farm type and characteristics, of course, but just as one example, the vegetable farmer who participated in the panel discussion I just told you about said that he had found for his farm, which has very heavy soils, moving to a permanent bed system with beds configured at just the right angle so that excessive rainwater runs off down permanently compacted paths between the beds has been working on his farm for, he implemented this almost a decade ago. And another pretty different way that we've heard about farmers approaching this is to invest in new equipment that allows you to cover ground more quickly. So for example, a wider planter or a camera guidance weed control system that can increase your working rate getting through the field, allowing you to maximize breaks in the weather. So for next steps on this project, first off, as I mentioned, this is not truly a part of my dissertation work, so I'm going to be passing these preliminary findings off to my fellow GradCAP scholar, Ruthie Sexton, who is she's in the same lab group that I am here at University of Maine, and this will become a piece of her master's research. And some of the things that she might think about working on next are more work looking at the historical weather and how this relates to agricultural field working days with soil moisture models factored into the mix, and ideally looking at a smaller spatial resolution than at the statewide level as I just presented data on. The goal, of course, is going to be prediction of field working days. If we can learn something about what the weather means for both next week and for mid-century, that can help farmers plan both in the near term and potentially prioritize infrastructure investments like, do you want to buy a wider planter? And of course, getting into that seasonality piece. So I showed that on average, we've seen almost half a day reduction in field working days since '96, but is that happening at different times of year could be a really important thing to dig into. So with that, I would like to thank my advisor, Eric Gallant, Ruthie, who helped get some of the data together for my talk today, and the other fine folks listed here, as well as the Climate Hub GradCAP program. And if you'd like to read more about what I'm up to, you can check out my website, skbirthisel.weebly.com. And that's all I've got for you today. But before we move on to the question and answer session, I'd like to remind you about upcoming webinars. Our next is about farms and farmer decisions, featuring presentations from Alyssa White, Brogan Tooley, and Mike Allen, and that will be Tuesday, October 30th at 2 p.m. So we do hope you'll tune in to that. And now we're looking forward to taking your questions. Feel free to keep typing them in the chat box, and I'll scroll back up to the top here and start moderating. So first off, a question for Gordon. Gordon, are most of the bird species in the area you're working in native, or are introduced species part of the picture?
It's almost completely native species. There's very few introduced species throughout the Appalachian Mountains. They tend to be, the introduced species tend to be more around urban areas and things like that. So all the species that I'll be looking at are native species.
Cool. And another question for you, Gordon. What specific factors are driving species to change their elevation? Is it food source, temperature changes, predators, or do we know yet?
Yeah, that's a really good question. It's not there's not a super clear answer to that, but I would say, just from my personal readings and inklings, that the changes in the habitat types and forest types that could be affected from climate is probably the biggest driver. So it's likely not necessarily a direct effect of the warming temperatures, but it's probably an indirect effect through the changes in forest types and habitat. But there also are several other factors that can play a role in that.
Cool. I guess the fact that we did this chronologically means another question for Gordon at this point in time. Number one, is the timing of spring important aside from overall temperature? And two, how does climate effects on predators factor into the changes you're studying, Gordon?
Another really good question there for the first part. I could talk for an hour or two about all the different potential factors that birds can adapt to. But spring timing can definitely be another way that birds can adapt to these changing conditions. So they could arrive earlier, or just maybe miss the timing of the spring bud burst and insect hatches. So if they're not moving upwards in elevation or moving along the elevation gradient, then we'd have to look at if they're arriving at different times, because that can be another way that birds can adapt. As far as the effect of predators, I haven't really looked into that. I wouldn't really think that would be a huge factor, but who knows. I would say, like, as far as predators for many of these songbirds, it's not really animal necessarily. There's a lot of mortality through migration, but I haven't really looked into the effect of predators per se.
All right, and I'm gonna one more for Gordon, and then I'll move on to a question for Manashi. And Manashi has asked me to pull up her slides to answer some of these questions for her. So don't mind me while I fiddle with the slides in the background as you answer your question, Gordon. Brooke asked, do you expect all elevations to experience the same climatic anomalies, changes in temperature and precipitation over a given time period? In other words, are high elevation communities more at risk of changing environmental slash habitat than low elevation communities?
Mm-hmm. I haven't really investigated how these climatic changes are variable across these elevations, but even if they're constant, I would say that these high elevation areas are likely more at risk just due to their greater isolation from other areas, as well as they're a little more scarce in their amount of area that's found in these high elevations, versus the low elevation areas are more widely ranging and more connected. So yeah, I would say that these high elevation areas are definitely more at risk. Don't really have any papers to back that up necessarily, but I'm sure you could find some that investigated that question in more detail.
Cool, thanks. Manashi, next question is for you. Is there existing infrastructure to allow water reuse, or is infrastructure and the need to create it also a challenge?
So interestingly, when I was doing research for these infrastructure questions, we already see that we are already using recycled water in the agriculture sector, and there is a practice going on. So here I am showing for the Maryland one. Like they already using 35 spray irrigation systems and 4 rapid infiltrations and 2 overland flow systems with the recycled water. And even for California, they extensively using recycled water, and their infrastructure is already built up. And for these kind of topics, I didn't face that much challenge yet.
And this maybe also gets at Kara's question. She asks, when you speak of water reuse for irrigation, is there a type of irrigation referred to, for example, overhead versus drip versus subsurface?
Yeah, so that's why we are actually looking for the type of discharge. So what happened in the, yes, in that discharging method means like from the wastewater timber plant, they discharging this recycled water to the natural bodies in 4 or 5 different ways. One is spray irrigations. They just spray the water in the environment. They some facilities using their recycled water to recharging the groundwater, some discharges to the rivers, and some actually evaporate this water in a ponding system. So in our research, we was thinking like which is already like discharging water like spray irrigation or evaporating. It's actually in our terms, it's like waste of water. Like you recycle the water, you use the energy and cost and everything, and then you discharging water just that way. So we actually look into that facilities which actually discharging the water in that manner, and then using this water to our agriculture sector.
Great. One final question for Manashi, for now at least. Do you know if efforts for increasing soil water storage capacity are being considered as a means to reduce water demand in agriculture?
So In our research, we are looking in a big scale watershed management. That means, like, I know there is lots of excellent researchers who working in a field scale, and they are doing this kind of research, and they did a very good job. So in our research, our focus is just to give the comfortness and flexibility to the farmers without using the reduction any irrigation amount. Just using recycled water as an additional source, like once there is no rainfall, but you need water to grow your food, to irrigate your land, and in that time you have a flexibility, like there is a source, you can take the water and then use it in your field.
Great, thank you. The next couple of questions are for me. One is, in the average field working days per week, are these USDA ERS data starting, ending with certain months? So this is a good question. Yes. The way this is reported is it's National Ag Statistics Service data, and it's data from the weekly crop progress reports. So, and we called to try to figure out how they calculate that or where that number actually comes from. And it's a survey of people in the state of Maine. So NASS will call up some friends in Maine, presumably, who work for Cooperative Extension or for the state or are experts, and will survey them about how many days per week were suitable for agricultural field work, and that's where that number comes from. And we tried to get a list of exactly where those places were coming from and haven't tracked down more specifics on that yet. But hopefully that addresses that question a little bit. And it's on a weekly step. And so for the analysis that I did, I limited myself to months of the year when we had pretty complete data, weeks of the year. So that ended up being weeks 17 through 44, which corresponds to kind of the end of April through the beginning of November, typically. Next question. Do you know if the decrease in field working days of 0.4 per week is a significant decrease? Yes, it is a statistically significant decrease through a couple of different methods of looking at that. I showed just a simple linear trend line in my presentation, and that was a statistically significant trend in the data according to that. And I also started playing around with more sophisticated time series analyses and chose not to present that data because I like to only present data that I 100% understand where it comes from, and I hadn't quite wrapped my head around the time series analyses, but it was a statistically significant effect with a number of different tests and methods that I've been trying to look at these data. So hopefully that answers that. Bill asks, Sonja, are the increases in precipitation mostly occurring during the growing season or at other times of year? I would need to double check about that. I believe that we're seeing increases in general throughout the year, but it could be that it's more, that there are some times of year that are seeing more dramatic increases. And if anyone knows better than me on that, feel free to jump in and help answer Bill's question.
Well, I'll just jump in. So there is an overall increase all year round, but there is a trend towards greater increases in the first half of the growing season up here in Maine.
Great. Thanks, Ivan.
Yep.
And Kara asks, is there a way to compare your decrease in field working days in Maine with crop loss data related to precipitation events, for example, hail, flooding, and rain? What a great idea, Kara. I'm going to write this one down and, like I said, pass it off to Ruthie to look into that. All right, we're back to a question for Gordon. Kyle asks, what were the factors that influenced choosing your study species?
We tried to keep it pretty broad so that we, since we don't know a whole lot of past trends, but probably the biggest factor was just making sure that we had enough, a large enough sample size for each species. So we had a low cutoff for the number of observations for a given species. And then If the species met that criteria, then we chose species that were more likely to be found in low or high elevation areas. So basically that they are found in a certain area along that gradient versus a bird that's just abundant across the entire elevation gradient. So that's about it for that.
Great, thanks. Another question for me. How many days a week do typical Maine farmers work during the growing season? Ooh, that's a great question. My impression is that pretty much every day that it is suitable to be out in the field and that the sun is shining, people are out working, especially during the first half of the growing season when you're trying to get crops in the ground. That's my impression, but I don't have great data on that, just sort of my experience of being friends with farmers. And then I saw one more question for Gordon up here. Gordon, do you have a favorite book or resource for learning about patch occupancy models? This is my question, actually. I need to do something similar with weeds pretty soon, and so I'm just curious.
Yeah, just for basic occupancy modeling, I like the book titled Occupancy Estimation and Modeling by Daryl McKenzie and other authors. Just gives a really good broad overview of occupancy modeling. It doesn't, I don't think it really gets into any sort of like meta-population patch type things, but just for a broad overview, it's a good book.
Great, thanks. And Bill typed a comment that presumably is related to how many days a week farmers work. He says 8 days a week, which sounds about right. Cool. Well, successful webinar, everybody. Does anyone have lingering questions? We're just about at time. All right. Oh, it looks like we've got one more question being typed in the chat box. Oh, all right. A comment. Haha, no doubt. Yes. All right, on that note, thank you everybody, especially our presenters today, Gordon and Manashi and myself. This has been really wonderful. I've enjoyed hearing about what we're all up to, and